Ready? Ready? Go ahead.
Good morning, I'm Jin Chao Hu. These are my teammates, Samuel, Julia, and Jason. Our group of internship company is Boatmate. Our research project is rigging defense. Yeah. This is our agenda. We start at history, then driver model, and last we'll explain the reliability of our solution.
All right. Hold on. When you're talking, don't jump around. Stand on the side so this is not in your eye. Stand on the side. A little bit more. There you go. So it's not in the light is not in your eye, right?
Okay.
Now stand still. All right, there.
Trailer is very particular. We often see on the highway. Boatmate company has been committed to production of high quality trailer. Customer only need to on Boatmate website. You can design their own trailer, and then the company according to the date provide or cancel for trailer, and then now the daily output is 20 to 22 per day, and our research is an important step after planning the work, and then observation and analysis in improve efficiency.
So this is the Toyota production system, commonly known as DPS flowchart. Now our part was found in the reducing variation, and this was going to in turn reduce our cycle time. Now the way we did this, or the way we found out was this is going to work was through our metrics, and the metrics were measured by how many boats we could increase. Now when saying this, we did touch other sections of this as well by saying cutting our workforce. We didn't have to do that, and respect for the culture as well there on the left.
This is the business case. This project is important for the company because one on-time delivery. Why? Because this company produces 5,000 or 9,000 trailers that are sold per year in Canada, USA, and Australia. So one reduce the lead time, and what the problem in this business case is the variation.
So here is the Ishikawa, the fish chart, fish flow. We created this to better understand where our issues were going to lie, and we found this. Two of the bigger issues were going to be in our workforce and our environment, as you can see highlighted here. This company used to create about probably 10 more boats than you're used to now. It's actually minimized, and this is due to the new boat customization options, as well as we also saw in the workforce that this had to do with it was a great group of people that were working on the line, but there was no fixed amount of people working on those lines, and to go along with that, there was no certain flow with these workers as well. So they're kind of scattered.
So with the Ishikawa diagram, we planned to map out all the possible mistakes, just from observation, all the possible mistakes that there could have been, big or small, and then later on we narrowed it down using the drive model.
Okay, so the start of our problem was to actually define what was going on here at Boatmate. And upon them bringing us on the two rigging lines that you can see here, we began communicating with the supervisors, managers, and the line operators to get an idea of what they were like, and maybe even give us a better idea of where the issue was going to lie. Because we knew our time there was short, and we were going to have to get more information than we could produce ourselves. And also from our visual inspections and our numbers, and through that, we kind of concluded that there was an unbalanced flow on these two rigging lines.
So the goals and scope of our project. The goal is balancing the lines, since that is what the company has, and we will focus on variation in the works and the processes, and the aspects we will choose to work on to achieve this is the work distribution and improvement of the rigging line flow through standardization of steps and procedures and tools.
As shown in this picture, after painting, there are 3 stations and 1 quality control. And when the set station need to the next link, the behind the trailer are 1 by 1 forward. And after quality control, if qualified, he will into warehouse. If not, it will be checked until qualified. The end.
So this is the different histogram for the process, and we can see 4 at each for a station. And we collect this data for analyze the frequency and the time the time that happened in each station. So this histogram is the total time in the process, and we can see that the majority of the trailers, the time is 6,000 seconds. So the critical path, the bottleneck that we identified in the value stream mapping, this is the current state. So the bottleneck we identified that is located between the station 3 and the quality control, and the root cause is the variation in the process for the disorganization in each station for the workers.
What was it? Again, say that one more time.
The root cause is caused by the variation that have each station, because in each station sometimes have different
number of people.
different number of people.
And like we said before, variation was our main problem. So it was we defined our system as a stochastic system. So therefore, we focused our efforts into the reduction of variation. And as my teammate said before, the bottleneck we found to be in quality control, and the root cause, the organized labor. And here we could better see the bottleneck in effect. Quality control takes up about 1,120 seconds, and station 3 takes 669 seconds, which causes station 3 to have to wait for quality control to come out. Since there is only one quality control and there are 2 rigging lines and they both merge into one, it causes a major waiting time in station 3.
So from that identification of where the root cause was, one of our teammates then used Pro Model, I believe it was, to then simulate what actually was going on to get a better idea of where, to make sure that we knew where that root cause was going to be. And we did find that it was, in fact, between here Station 3 and the quality control. And this in turn helped us bring balance to, is going to in turn help us bring balance to this rigging line.
So how we're gonna measure like our improvement through the lead time, and this assumes that the cycle time and wait time will also be reduced. And we were able to see this through simulations. Then project objectives is the balancing of the line, and we will achieve this through the reduction of lead times. And well, the other way around. We will reduce lead times through the balancing of the lines, which we will do through the leading indicators, reduction of variation, which is through the establishing fixed number of workers at each station, and determining and capacitating workers for specific tasks that they will each perform. And besides variation, we will also focus on flow. And the way we do this is through the standardization of tools and procedures and organization of work area. And by saying this, we mean that once a worker is finished with their station, their task, what they currently do is they go back in the line and they help the stations in the back, where they should be looking from side to side and then going forward if the person next to them is already completed. This way you finish the task that needs to be performed ahead of time, so quality control can have less time working processing so you can get more trailers in and out quicker. And the result of all this would be 28 to 32 trailers being produced.
Which is in turn our lagging indicators.
This is the future state of the value stream mapping, and we can see that have the same number of stations, but the difference is the waiting time between each station. So we make some change in the station that we can see in the next slide.
So here, as you can see, these stations 1, 2, 3, and 4, as they're laid out in front of you, those are the current way the stations are laid out in step-by-step form. Now, as you can see, color-coded here on your right, this is going to be our future state. So as you can see here, these two green are going to be then installed in station 1, and so on and so forth here, yellow to 2 and blue to 3, as you can see here. And then we'll get to how that affected our system in a second.
Okay, so after determining the tasks to be performed at each station, we had to determine the number of workers per station. The way we did this is through a method developed by Neil. He's the author of an industrial engineering book, and it was further developed by General Electric Company. So what this does is determine the number of workers per station, and we determined that the number of workers per station, well, in station 1 is going to be 3, station 2, 3, station 3 will be 2, and then station 4, which is quality control, will be 1. And the way we adapt this to our system is that we would have 2 workers in station 1, 2 workers in station 2, 1 worker in station 3, and 1 quality control. All right, so now the third worker, to compensate for the third worker, we're going to have a floater that goes on each rigging line, since there are 2, and this will compensate for the third worker and the second worker in station 3. And station 4 will remain the same since there is only 1 quality control.
And these are the different stations with low holding time, the fixed number of workers. And we will use the data to this.
So this is the simulation results, and we can see the current state and the future state. The important data in these results are the total exits. And the first station have 18 total exits, and the future have 32 total exits of the system. And this part is important that during the process have others 6 trailers. So the total here is 20 seats, and here is 32.
So here is our future proposal for Boatmate. And as you can see down here, there's going to be 13 workers on the line, and they're evenly distributed with 1 floater at line 1 and at line 1 and line 2, as my teammate has said. Now, in implementing this, this should help bring balance to the rigging line. And the way this is going to happen is that all the steps here in quality control are then going to be absorbed here in station 3. And so when we get to the company on Monday, we are going to then practically implement this into their rigging line. And another part of our the way we're going to implement all of this is to have a well thought out sustainability plan. Now, this is going to come from maintenance. Now, this maintenance is not necessarily on the machine itself, but rather the people. As we gave out surveys, as we talked to the employees, we found that we found a common thing among them, that they would have liked more supervision, and not as much as like telling them what to do, as much as it is them being out there and they can be there for questioning and there to maybe lend a helping hand or to go grab something for them if they need it, because we saw that's where a lot of the wasted time was, and so that's going to be one way we're going to maintain the system. And then we also saw that our proposal was not going to impact the culture in a negative way. We found that they're a very loyal group. As we were giving out these surveys, they were very reluctant to give us some of the feedback. and this came from questions like which station was most unorganized, which station ran the slowest, and they did not want to. They didn't want to answer any of those questions, and you know, from our perspective, we didn't really take that into account since that was never really the point they were trying to, you know, do that. But we found that was very, you know, some of them didn't even want to answer the surveys either. But you know, anyway, they were. Our proposal is not going to affect the culture in any way. We actually think it's going to improve.
Adding on to that, the proposals that we have and the answers that they gave us from the surveys, it showed that their own solutions that they personally propose is in line with ours. So there will be no conflict between our solution and their own opinions.
Okay, so here a part of our sustainability is going to be reliability. They kind of go hand in hand, and it's going to be kind of hard for y'all to see. This is an add-on to our presentation. But here you can see a mock schedule of what we want to propose to the company. We do not have any concrete numbers from the company of their scheduling, but we kind of wanted to show this to them. And so at the beginning of every day, maybe start out with the lighter load of boats first, so maybe the smaller rigs, and then we're going to increase into, as you can see, there's green, there's yellow, and the red. So it's obviously a little bit harder. So we're going to say maybe we're going to put those at the end of the day. So then at the beginning of the day, people can begin to set up for these more difficult boats. And in turn, we suspect that this is going to lead to reduced cycle time.
And once we are able to cut down on variation and disruptions and improve the flow, we will automatically increase or enhance the quality of life within the system of the workers, and therefore increasing the reliability of our plan as well.
Questions and for anybody? Let me tell you what I think you did. From an overall systems or organizational perspective, one of the issues I think that Boatmate has is on-time delivery of trailers. I think that's what you try to do is to see if I could look at a bottleneck process of delivering these things, and the bottleneck process you have identified to be rigging. Well, if it's not, then you have to indicate it, but you're going to fix rigging and you're going to fix that, right? And what you're trying to do is, in the rigging process, to be able to reduce that cycle time. How you are going to reduce that cycle time is, you know, when you say single piece flow and balance, you're trying to balance that line out because they already have a single piece flow, you're balancing it. The problem with the balancing is because you have a variation in the boat and the amount of time that each of these boat trailers takes. Okay. Because it is people-driven system, it's a people-driven system, it's not like I'm going to put it in an oven and the oven dictates the time. You have come up with 3 different kinds of solutions. Scheduling people, culturally the maintenance or the supervisory kind of thing, and then the material setup kind of issue. So you have 3 different solutions for people to reduce variation, to improve the balance, to reduce the cycle time, to improve the throughput, to increase on-time delivery of that organization. This is your lagging and leading indicators. Because you have done a simulation, would have used the simulation to show what the existing problem is. I wouldn't use the simulation to the end. Use the simulation to the beginning. To say, watch, when I run the simulation, look at my cycle time, look at my throughput, look at my this, look at my this. This is all messed up. And yes, this looks very similar to the numbers that we have seen. Subsequent to that, you decided that this was a stochastic process, which is fine. And I think that's correct, because the process, the steps are repeatable, but the time that it takes is. So you're trying to reduce variation, and that's what you have done. So you state that this, in the rigging system, for example, one of the things we're trying to do is to reduce the impact of variation. And this is the way we do it. I would run the simulation with perfection and say this is the theoretical best that you can do, but that's not where it is. And then you would add the amount of variation and disruptions into your simulation to make it realistic. Once you have figured out how much variation you have reduced, okay, I would put it back in the simulation and show them the results all the way up. If you do that, I think the rest of the work that you've done is fine. Okay? So put it in that order and clean it up. Right? Other than that, I thought the project was, your thought process was good. You're doing it, it just needs a little bit of refinement. All right? Good job.
Thank you.
All right, so nobody claps now? Enrique, you notice? There is a selected clapping.
They're nervous, I guess.
What's that?
Nervous.
They should be nervous. Who's next? Huh? All right, go. So make those changes and